Welcome back, folks. Last section of the chapter 1-8, we're talking about perimeter, skipping circumference, and area of basic shapes. Objective is to find the perimeter and area of basic shapes. Perimeter and area are another foundational part of the geometry we're doing in chapter 1 here. There'll be topics we come back to throughout the year. Like it says here, we're just going to do some of the basics today. First things first, what do we mean by perimeter and area? Perimeter of a polygon is the sum of the length of its sides, and area of a polygon is the number of square units it encloses. Okay, so perimeter is the sides, what's around the outside, whereas area is the space it encloses, what's on the inside. Perimeter around the outside, area on the inside. And then our book gives us a few formulas, okay, for this section. We're actually going to skip triangles and circles. Like we said, we're going to come back to this a few times through there. We're going to worry about squares and rectangles. And actually, since a square is a rectangle, all we really need to know is the formulas for a rectangle. Perimeter, it's here, but you don't need the formula. That's just going to be the four sides added together. And area then is the length of the base times the height, okay, or length times width. That'll really be the only formula we're using here today. All right, first question, finding perimeter of a rectangle. Part A says, the botany club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? In other words, what's the perimeter of both the garden with the path around the outside? Okay, dimensions of this larger rectangle. And the trick is for this, since the entire path is 4 feet wide, if I want to figure out what this kind of height of this rectangle is, I'll take the 22 and add 4 to the top and also add 4 to the bottom. 22 plus 4 plus 4, that's going to give me a height of 30 feet. Okay, same idea for the base or the width. 16 plus 4 on the left, plus another 4 on the right. Need to add to both sides. That'll give me a 24. And then once I have that, the perimeter is just going to be equal to the 4 sides added together. So we can say 30 plus 24 plus 24, which will give us a grand total of 108 feet. And again, trick with this is when we add a border to something, we need to add that dimension to both sides. Okay, a little segment addition from earlier this chapter. Okay, part B is the same idea. If you need to draw a picture out for it. But why don't you take a second, pause the video, work that one out, and then hit play to check your answer. Problem 2, we're finding perimeter in the coordinate plane. Part A asks, what's the perimeter of triangle LMN? Here's triangle LMN for us. Okay, remember, perimeter is just adding up all the sides. So I have one side length of 1, 2, 3, 4, 5, 6, 7, 8. Another side length of 1, 2, 3, 4, 5, 6. Now the issue with this one is this diagonal side length. I can't just count that out. What I'm going to need to do to figure out the length of LN is actually apply the distance formula from the previous lesson to this segment. Okay, let's go ahead and do that. Remind you how to do that. L looks like it's at -4, 3. And N looks like it's at 2, -5. Let's use the distance formula on that. That was our d is equal to square root of x2 minus x1 squared, y2 minus y1 squared. Okay, I'm going to set that up and fill things in a second. Okay, so x2 minus x1, subtract the x's, order doesn't matter. So we'll say -4 minus 2. And then in the same order, subtract the y's, y2 minus y1. So we'll say 3 minus a negative 5. So in other words, 3 plus 5. And then we can just reduce that down. That'll be square root of negative 6 squared plus 3 plus 5 is 8 squared, which will be negative 6 squared is 36. Okay, remember, when you square a positive and a negative, you get a positive number out, plus 8 squared is 64, okay, which is equal to square root of 100, which I know is just the 10. So after all that, we know the third side is 10 units long. And then from there, you did the hard part. Don't forget to finish the problem. Perimeter is going to be equal to 8 plus 6 plus the 10 we just found. All right, so in other words, 24 units. Part B is the same idea. Why don't you pause the video, work through that one, and then click play to check your answer. Problem 3, part A says you want to make a rectangular banner similar to the one on the right. The banner shown is 2.5 yards wide and 6 feet high. To the nearest square yard, how much material do you need? Okay, if we're talking about material to make a banner, we're talking about finding an area. So pretty simple area problem. The one tricky part here is I want my answer in square yards. And notice I'm given one dimension in yards, but the other one is in terms of feet. So first thing I'm going to need to do is to convert that 6 feet to yards. Okay, for that, I know that 1 yard is equal to 3 feet. And I know that there should be less yards than feet. All right, therefore, what I'll do is I'll divide this 6 feet by 3, which will give me 6 feet is 2 yards. Okay, so simple conversion. Might have to multiply, might have to divide, all depends on which direction you're converting. My area then, I'm going to say is equal to just the base of the rectangle, which is the 2.5, so we'll say 2.5 yards. Okay, times the height of the rectangle, the 2. And when I multiply those together, I get 5. So we'll say 5 yards squared, because we're talking area, so we're talking square units. All right, I want you to take a second, pause the video, work through part B, and then hit play to check your answer. Last thing we're going to talk about today is the area addition postulate. Just like we have the segment addition postulate that says we can add lengths together, or the angle addition postulate that says we can add angle measures together, the area addition postulate says that the area of a region is the sum of the area of its non-overlapping parts. Let's show you what we mean by that. In problem 4, we're finding area of an irregular shape. Now, here's an example of an irregular shape, a shape I don't have an area formula for. But if I split this into figures that I do have the areas for, area formulas, so as in rectangles, the area addition postulate says I should just be able to add those 3 rectangles together, their areas, and get the area of the entire shape. Okay, now before we do that, let's deal with these markings quick. Now this very top side of length 3 centimeters has a single dash next to it. That means that every other side with that single dash is going to have a length of 3. Same thing with the left side here. It has a length of 9 centimeters. It has 2 dashes, meaning this bottom side with those same 2 dashes is going to have a length of 9 as well. Okay, from there we can find the areas of each of these rectangles. First one, base times height, just be 3 times 9, which will give us a 27. Okay, middle one we have a 3 times 3 plus 3 is 6, which will give us an 18. And in the bottom right corner we have a 3 times 3, which will give us just the 9. Alright, total area will be those 3 parts added together, 27 plus 18 plus 9, and that'll give us a 63 centimeters squared. Alright, now there are other ways to cut this figure up. We could have cut laterally with our rectangles. We could have turned this into 6 smaller squares. Okay, as long as we cut it up and find the areas correctly when we add them together, we should get the same answer at the end. Let's run through one more example together just to show you a trick that works out for these types of problems in some cases. Again, what's the area of the figure? Figure is a irregular shape, a rectangle with a hole in the middle of it basically. Okay, now what I could do is I could split this into, let's see here, 1, 2, 3, 4 separate rectangles, find their areas individually and add it all together. Okay, but for this one there's going to be actually an easier way. Since we know how to find the area of the rectangle around the outside, and we can find the square in the middle, what I can do to figure out everything but the square is take the total area and subtract the white part, and that'll give me my shaded, we'll say, kind of the bluish area that we're looking for. Okay, total will be 12 by 8. The white part will be 4 times 4. Okay, 12 by 8 is 96. Minus 4 times 4 is 16, which will give us a total area of 80, and we can say inches squared.